Thank you very much, everyone, for joining us on the Cloud Native FM podcast. And today we are talking about Service Mesh. And my guest of this show is today is William Morgan, the co-founder of Linkerd. Thank you very much, William. And let me tell you your life at Buoyant and how the things working there as well.
Well, hi, Simon. Thanks for having me. It's great to be back. So
Yes, absolutely.
you want to hear about life at Buoyant?
Yes, absolutely.
Yeah. Okay. Wow. There's a lot to say. So let's see. There's kind of there's two big things we're working on. Um, One of them, of course, is Linkerd, and then one of them is Buoyant Cloud, which is our managed Linkerd service, and the two kind of go hand in hand because of course we keep adding features to Linkerd and we keep making Linkerd more powerful, while still trying to keep it simple and lightweight. But the reality is that running software is always painful, and you have to run Linkerd on your clusters. So we try and ease some of that pain with Buoyant Cloud. So the stuff that's coming up soon is we've got a Linkerd 2.12 release. It's actually later this month, probably I think it's next week. So it might be the first time I've said that publicly. Yeah, so Linkerd 2.12 will be out next week, and I'll tell you all about that. And then at the same time, Buoyant Cloud will have the ability to do automated upgrades of Linkerd from any 2.10 or later cluster. We should be able to take you automated all the way up to 2.12.
Yes, absolutely. Always talking to you around service mesh is really feels like a put a smiles on my face. Like you're the concept behind this technology that being very hot ever since the Kubernetes and service mesh in there. Yeah. So let's tell first people like who are really new, like listening to us today, and they never heard about service mesh or
Yeah.
Linkerd before.
Yeah.
So try to explain to those audience like what is service mesh in 2022 specifically.
Yeah. Okay, so here's the idea, which is you're running Kubernetes, and you kind of have to start there. We could have had service meshes before Kubernetes, but it would have been complicated. There would have been a big operational burden. So we're mostly talking about life in Kubernetes. And basically, when you're running an application on Kubernetes, you're typically splitting it into different services. Maybe we call them microservices. Maybe we don't want to use that word. Doesn't matter. And those services are talking to each other over the network, right? And this is all running within your Kubernetes cluster. And so those services could be written by different teams. If it's a bigger company, it could be all written by the same person, could be in different languages, could all be in the same language. Doesn't really matter, right? And what the service mesh does is it's a layer that kind of sits in between Kubernetes and the application, and it adds a bunch of features. And it adds features that are around observability and security and reliability, right? Those are kind of the three buckets. And they're not really features of the application, right? They're features of the platform. So what a service mesh does is it enhances Kubernetes. It provides a bunch of stuff that Kubernetes doesn't provide, not because Kubernetes is bad, right? But because Kubernetes has a very well-defined scope, right? And it says, this part, we're going to take containers, we're going to orchestrate them across your machines, we're going to give you objects like replica sets and deployments or whatever, and like that's kind of where we're going to stop, right? But as soon as you start talking about things like, oh, well, I want mutual TLS between my pods, right? I want encryption and authentication, or I want security policy. Only certain pods are allowed to talk to other pods, or I want to understand the success rate of these services. Are they healthy? Are they not healthy? Are they 80% healthy? Kubernetes doesn't actually give you any of those things. And so you can either build them into your application yourself, or you can use a service mesh. And the way that a service mesh works, which is maybe kind of the next interesting thing, is it works in this very strange way, right? A way that prior to Kubernetes would have seemed totally crazy, and still seems a little crazy, but actually Kubernetes makes it manageable. So the way it works is we actually add a tiny proxy next to every instance of every application. So if you're running 3 applications or 3 services, let's say you're running 3 services and they have 10, they're each, have 10 pods, right? Then we've added 30 proxies into your system, right? And that sounds crazy, except Kubernetes gives us a way of doing that basically automatically and making them more or less invisible to the application and reducing, the amount of operational kind of pain we would have to do that. And once you add those proxies everywhere, then those proxies can start doing things for you, right? They can look at the incoming and outgoing traffic to the application. They can add mutual TLS. They can measure everything and give you metrics, and kind of all the features of the service mesh work from the fact that you add those proxies in kind of this transparent way to every pod on Kubernetes. So that's the 10,000 foot view of what a service mesh is and why you care about it and how it works.
Yes, absolutely. Thank you very much for explaining these complex concept in really simpler way. And also, like, I think, like, if you've been in the past with some Twitter and other microservices where so much communication happening in
Right.
everywhere, and you spend life there prior to being the life at the Linkerd and the Buoyant. So before, like, when there's no link, there's no Kubernetes, as you mentioned, it's really difficult for to understand this concept. Like, every application, like application A have want to talk to application B, that you
Mm-hmm.
need a load balancer in between them.
Mm-hmm. Right.
And when we think about, like, there are 10,000 services, we
Right.
need 10,000 load balancers for
Right.
it. The
Right.
proliferations of these load balancer.
Yeah.
And then came up with in the Kubernetes world, we have a very neat way of setting up the sidecar
Right.
that give you the same flexibility, but you can talk to the control plane, like, I am the service A, I am a service B, those register to those, and you can do mutual TLS, service discovery rules, like if A talk to B, or B talk to A, or C talk to B. So I think that's a really shiny way. I think that's why this idea is eventually hit, because it's look really simpler in the picture, and
Right.
also implementation as well.
Yeah.
So
Yeah.
absolutely.
Yeah.
So for the next question, like, is right now, I think there is so much happening. Like, when we look back in 2018 and 2019,
Mm-hmm.
we see a lot of hard debate. Everything is talking about service mesh. Eventually, it's every day, every year we have new implementation of service mesh.
Right.
But
Right.
luckily, this noise is getting slower and slower
Yeah.
in
Yeah.
2022.
Yeah.
And eventually, this noise is getting louder again because of the concept called eBPF.
Mm-hmm.
So I think, so for the people, I think people need to understand. I think you're the best person to ask this question. Like, what is sidecar
Yeah.
and what is eBPF? So
Yeah.
we can't misunderstand those two
Yeah.
terminologies.
Yeah. No, that's right. So that's, this is now a hot topic in the Kubernetes world. And I was feeling a little optimistic because usually, the way technology gets adopted is there's a lot of buzz, and that's good and that's bad, right? It's good because lots of eyeballs come to your project. It's bad because, oh, everyone else looks at it and says, oh, well, maybe we can do this. Well, let's get involved. Oh, we need a service mesh, right? And so you end up with 12 different service meshes. And if that buzz starts to die down, then that's actually healthy, right? Because it means, your project can, the projects that are solving problems and that are based on engineering, and like, trying to solve problems for users will succeed, and the projects that are just based on marketing will kind of fall off. But now there's more buzz, so we're like back into this world of, yeah, what are we trying to do here? So you use this word sidecar, which I like a lot. When I talked about, 5 minutes ago, just about how we add these proxies everywhere and we put them in the pods, that's a sidecar model, right? And what it means is that proxy, in Kubernetes terms, a pod is one or more containers, right? And that proxy gets inserted into the pod, and that pod is kind of your unit of operation in Kubernetes, right? It gets, everything in the pod shares the same IP address. It's in the same C group. Like, everything in there basically functions as a unit for, for purposes of, like, operations and for purposes of security, right? You're kind of manipulating pods. You're doing stuff at the pod level, right? And so recently, right, there's been a big kind of, I wouldn't say debate, but there's been interest, right? There's this been idea that, like, hey, maybe instead of doing this stuff in, doing all this complicated networking stuff as user space proxies, we can actually do it in the kernel with eBPF, right? And, like, that's an interesting idea because, all the TCP stack, right? Everything layer 4 or below, if you're familiar with the OSI model, right? That all happens in the kernel, right? Your application doesn't have its own TCP stack. So how come we have to do all this layer 7 stuff up in, and we have to add these user space proxies everywhere? Can't we just push all that to the kernel? And the answer is basically no. The answer is you can push some of it into the kernel. And I wrote a long article about this, actually. If anyone is really interested in this and they want to read, I think if you just search for eBPF and, future and sidecars and future of the service mesh or something, you'll probably find it. So what eBPF is, let me take a step back. What eBPF is it's a cool, relatively, well, it's not actually that new, but it's becoming popular way of running code in the kernel itself, right? So your application can take a bunch of code, and instead of running it in user space, you can run it in the kernel with a lot of asterisks, right? And I'm going to talk about what those asterisks are. But why would you want to do that? The biggest reason is if you're is for performance, right? Like especially around network, there's like really interesting observability features you get, but in my world, the network aspect is the interesting thing. If you're analyzing packet data from the kernel, right? Let's say you want to look at a packet, or we want to count the number of packets that are going to this particular IP address or something. If you were to do that in user space, it's really, really hard to keep up, right? Modern systems can be handling billions of packets every second. So for you to have a user space program that is doing that kind of manipulation, it gets very difficult, right? So with eBPF, you can kind of do that in the kernel itself, right? You take this piece of code, you say, hey, run that in the kernel, and then you don't have to bounce back and forth between kernel space and user space. That's the slow part, is moving between those two contexts. So with eBPF, you can just do that in the kernel, and everything's fast, and then you just report the results to the user, and everything's fine. But the big challenge is that running code in the kernel is super dangerous. Yeah, that's the article. Yeah, that's the one, right? And so, if what I'm saying today doesn't make sense, you can just read this article. I probably explained it better. So running code in the kernel is really dangerous, right? Because the kernel is like, it has access to everything. It has access to everything's memory. It has access to everything's, every process that's running on the system. So you have to be very, very careful, right? And the way that eBPF does that is it has this thing called a verifier. And before any eBPF code can be run, the verifier imposes a bunch of restrictions on it. And those restrictions basically are very, very limiting. So you can't take an arbitrary program and run them in the kernel. You have to, go through a lot of hoops. You have to make very, very simple programs. The complexity of the program cannot be too big, or the verifier will reject it and it won't run it. So for all of those reasons, basically eBPF is capable of simple things, but it's not capable of complex things. And so in the networking world, if you're doing the example I had before, you're doing like layer 4 information processing, right? We're counting the number of packets that went to an IP address in a pod. Well, that's very straightforward to do in eBPF. If we're doing something complicated, like we need to do a TLS handshake, or we need to do, we need to parse an HTTP 2 stream, right? That's basically impossible to do in eBPF, at least not in a practical way. So the way that we have to do this, right, if you want to make a functioning system, is you do portions that are in the eBPF and portions that are in user space. Okay, does that make sense so far? So either way, you have to have this user space component that's basically a proxy doing the part of the work that eBPF cannot do. So now the only question is, well, do we put that user space proxy at the sidecar level, or do we put it at the host level? And that's kind of where the debate is, right? Because people don't like sidecars for bad reasons, not for good reasons. So they say, hey, we want to have a sidecar-free service mesh, and we're going to do it with eBPF. And what they don't tell you is, well, yes, but you're still going to have a user space proxy, and it's going to be at the per host level instead of the sidecar level. And that actually is a lot worse, right? Having that user space proxy at the per host level, right? You need a proxy, again, because eBPF can't do complicated things. But having that user space proxy at the per host level means that you are now outside of the C group. You're outside of all the isolation guarantees that the kernel gives you through containers. Like everything we've worked to achieve with containers in the first place, you kind of throw away, and all this traffic is going through this per host proxy. It has all the TLS secrets for all, everything that's running on the host. Like it's a real step backwards. And in that blog post, I kind of outline why. It's a real step backwards for security. It's a step backwards for observability. And for most importantly, it's a step backwards for, I don't know, most importantly, it's a big step backwards for operationalization, right? Actually operating those per host proxies is a big mess. And the reason why we know, right? The reason why we know is because Linkerd 1.x, the original version of Linkerd actually ran in a per host model. And we thought it was a good idea, right? We were like, oh, you don't want sidecars everywhere, do it per host. And it was a real pain. It was a real pain for users to operate that thing. And the security boundaries were like very scary, right? So we switched to sidecars and everything got a lot better. So basically at the end of this, where I think we are is that eBPF is really valuable, right? And there's lots of stuff you can do with service meshes, especially offloading kind of like pure layer 3, layer 4 work, right? You can do that with eBPF, but you have to have a user space proxy. And if you're going to have a user space proxy with eBPF, it should be a sidecar, not a per host proxy. And then you have the best of both worlds, right? You have all of the isolation guarantees of sidecars, plus you have all the performance guarantees of eBPF. The only thing you don't have in that world is you don't have a nice marketing message where you can say, oh, goodbye sidecars, we're taking down sidecars, right? Like you don't get that, right? So you don't get the marketing benefit, but you get a lot of engineering benefits. So that's kind of the direction we're looking at with Linkerd, is keep the sidecars because they're really good for security, really good for operability. Add eBPF as a way to speed them up, but it's an enhancement. It's not anything that fundamentally changes what a service mesh is or how it operates.
Yes, absolutely, absolutely. That's a wonderful explanation. I think you summed up your article in a very shorter amount in this discussion. That's
Nice.
wonderful. And also, I think for a user like me, I'm using the Linkerd. Like it's far more easier to me to understand the sidecar compared to the eBPF because that's kind of a networking concept.
Mm-hmm.
You
Yeah.
need to be have underneath the how the kernel stuff work. And for developers like me, especially, they don't want to delve into the kernel and see what's happening there. So
Yeah,
we
yeah. I
so
didn't really talk about that in the article, but eBPF is like really hard to debug. It's really hard to understand. It's like running as part of the kernel. Like there's a bunch of kind of practical considerations. Not every machine supports it. There's like a bunch of stuff, but I feel like those actually can be addressed with time. Over time, we'll probably make that a little easier to understand and to operate. Right now, it's a little difficult, but I don't think those are fundamental challenges to eBPF. I think in 5 years from now, we'll probably have solved that stuff. But what we won't solve, is multi-tenant proxies versus single-tenant sidecars. That's the thing that's like a fundamental architectural difference.
yes, absolutely. I think like for the idea, like you being in the past where there is no sidecar, but there's people are using the service mesh technologies in different way prior
Mhm.
to the Kubernetes. And you look like we have a load balancer issue, we have a firewalls rules, and we have a communication channels, how to encrypt in communication between them. So people realize like if we can offload the responsibilities to sideguard and sideguard just talking to the control plane, it's a lot more simpler and lots more easier. So like if we going to choose that route of like the eBPF or the Linux or the kernel space, like we have to make the assumption like this is really the need. Like we want to debug our application, we want
Right.
to see the logs, where people see the logs if to go away the sidecar because logging is everywhere because we know we make breaking changes to the application and application can be break
Yeah.
during any stage of the lives,
Right.
and it's difficult if you don't have any logging or tracing enabled in your infrastructure. Like I am a huge fan of the observability and tracing, and I think everybody else, like because when you deploy your application to the production environment, the next big challenge for you, how my application is observing at the live traffic, and
Right.
you need to look at these logs.
Yeah.
So if we can adopt the eBPF, like where's the logs happening in that space, like is it still going to be used the sidecar behind this eBPF, or what's happened to the sidecar if we if what happened to the logs if we just use eBPF as of today?
Yeah, so it has to pair with some user space proxy. So today I don't know, but the way it would work in Linkerd is that sidecar proxy is still going to be emitting those logs, it's still going to be emitting the metrics, and eBPF will just be something that it uses to offload certain types of work. Like occasionally, a lot of times, what the Linkerd sidecar proxy doing is this complicated stuff where it's terminating mutual TLS, and it's parsing a bunch of gRPC or HTTP headers, and it's doing enforcement and blah blah blah. But sometimes you're asking it to do something very simple. Sometimes you're telling it, hey, just proxy this TCP stream, and don't worry about what's inside, right? It's like application initiated TLS. You're not going to be able to do anything with it anyways. So just proxy through, and that kind of stuff you can offload to eBPF. So I think in that world, at least for us, we would make it so that it was kind of seamless, right? And like it feels like just like the rest of Linkerd, the sidecar is how you're thinking about stuff. Here's the logs, and the fact that there's some eBPF magic going on under the hood is kind of an implementation detail, right? And I think what you're getting at with that observability stuff is that, as an engineer, right? When you start out, when you're like a junior engineer, you can be very focused on performance. You're like, oh, look at all this, all this stuff that's like slowing us down. First, we're running stuff in containers. Then we're running stuff on a VM. Then we're doing all this stuff in the application. Then we've got multiple applications. Why don't we, why are we using microservices? They have to make these network calls. That's really slow. That should be a monolith. And, then we just get function calls, which are really fast. And why are we writing in Go anyways? Go's slow. We should be writing in C, right? Like as a junior engineer, it's very easy to find all the ways where we're slowing stuff down. And then I think as you become more mature as an engineer, you realize in a lot of cases, the limiting factor here is like the human being, right? We're the problem here. So what we do is we sacrifice performance, and the history of computing is all about sacrificing performance in order to make things easier for humans to do, whether that's to operate the system or to understand what's happening or to make it secure. So the whole history of computing is like we're trading off performance in order to have VMs. We're trading off performance in order to have Kubernetes. We're trading off performance to have higher level languages, and that's all to make it easier for human beings, because that's actually the constraint when you're building a big system. And it's only in very, very rare circumstances where you say, oh, you know what? Performance actually it's more important than human understanding. Like, high frequency trading, every nanosecond matters and costs money. Okay, fine. We're going to make that as fast as possible. We're not going to do any of that stuff with Kubernetes, right? Because we care about performance more than anything else. But for the vast majority of applications, the limiting factor is the human being. And so all of this kind of technology we're building up is basically designed to make it easier for humans to operate this and to understand what's going on.
Yes, absolutely, absolutely. 100% agreed on this point. Like, it's absolutely like if we're talking about like, do you give the performance penalty or do you give the learning steep curve? We have those solutions that have very performance efficient, but at the end of the day, operating those systems, you need a 2-3 months of training to operate those things, and that's really difficult because it you have a performance, but you have a steep learning curve. You need engineers, and when you give up some part of the performance and you have a very easy way, like I have to just run this command, everything's stood up and go away. And for the performance, you have so many solutions to work with. So I think human readability is right now. I think if we look at the CNCF ecosystem, I think those projects that have easier to install, easier to understand, easier to run, easier to deploy and manage, they are far more successful than those having so much features in it and they are difficult to operate and manage.
Right. Yeah, exactly. I mean, if we really wanted performance, we don't even need to use eBPF. We can write this all as a kernel module, and you load it as a kernel module, right? And like then we'll run directly in the kernel, whatever code we want, But the operability of doing that would be, that'd be painful. That'd be so painful to do things that way. So we don't do it because we care about the humans.
Absolutely. And before we go to the other topic, like one more question on the eBPF side. Like, let's say if we adopt eBPF Linkerd as of today and Linkerd going to use in both direction, what happening when we installing the Linkerd? Is
Mhm.
there are new commands popping up into the Linkerd CLI, or is just staying the same as it is as of today?
Yeah, so we're only in the very earliest stages of kind of designing, but I think our goal there would be no, there's no new commands, there's no eBPF command. Like I think you as the operator shouldn't really be aware. I mean, maybe we increment some metrics when we're doing eBPF stuff, so you can kind of tell whether it's on or off. But I think for us, the proxy can do everything that you need to do in user space. So it's really an optimization feature. So if eBPF features are available on that platform, we can try and enable them by default, and if not. But like what the proxy is doing is kind of the same. So I think it would be more or less transparent to the user, except if we could use eBPF, then things like layer 4 proxying, just proxying a raw TCP stream without doing any analysis will be a lot faster. Now, whether that's an actual critical part of your application, right? It's like that's another question, right? Like if you look at if you look at an actual real life microservices application running on Kubernetes, right? The vast majority, and we see a lot of these because we help companies around the world adopt Kubernetes. Vast majority of the latency, it's not coming from Kubernetes. It's not coming from the hop you have to make through the sidecar proxy. The vast majority of the latency is coming from the applications themselves, or it's coming from the data store. So, if we make Linkerd as fast as we can, right? But we don't sacrifice usability for it, and we don't sacrifice security for it. And Linkerd is just like, one portion, one very small fraction of the actual latency of a real application. So there's only so much benefit you can actually get by speeding it up anyways. I mean, we'll speed it up. We'll make it as fast as we can, but there's only so much benefit we can actually give you because your problem is probably somewhere else.
Yes, absolutely. And one comment from Kai Hansen that it does feel like quite the balancing act to scale Kubernetes with all the advanced projects moving in parallel while
Yeah.
still trying to keep the cognitive load on manageable
Yeah.
levels.
Yeah. I agree 100%, and I have a lot of sympathy for folks like Kai who are in this Kubernetes ecosystem where everything is moving so fast and there's so many projects, and like even keeping up to date with Kubernetes releases is not trivial, right? Like the Kubernetes releases on a very aggressive scale, and and then the projects have to update, and then there's new projects, and the old one, there's a lot of marketing noise, and I don't know that there's a great solution other than I think the way that I would address it is you've got to decide. I like this idea of innovation tokens, right? Which is like if you're working on a project or if you're working on a company, the amount of mental energy you have, right? The amount of things you can really innovate is limited. And let's say you get 3 tokens, and you've got to decide where are you spending those 3 tokens, right? Where are you spending your mental energy? And what of that is going to be the most important for your business or for your project or whatever it is. And I think if you're very explicit and intentional about where you're allocating your energy, then you can start making decisions that are like, okay, do I want to become a service mesh expert? Do I want to invest my time and energy in learning all of the management and tuning and whatever else is required? Is that actually useful to my business? Well, if you're working at Buoyant, yes, right? We have to be service mesh experts. But if you're working at a company that uses a service mesh, well, you probably shouldn't be spending too much of your brain on the service mesh. So pick the one that's simple, pick the one that is not going to be annoying to you, pick the one that is going to not require a whole lot of time and energy, right? And obviously that's Linkerd, right? That's why we designed Linkerd this way. But I think it's really important because the other thing you have as an engineer is you get excited about stuff, right? This is why we're engineers in the first place. Oh, there's cool technology, it does these 30 different things. Oh, look at all this cool stuff I can do, right? And that's good for learning, but you can't do that for every aspect of your stack, or you end up with a lot of really complicated stuff that doesn't quite work together. So focus on simplicity and ease of operation for the stuff that is not important, and then spend your mental energy on the parts of the stack that actually are going to make a difference to your business or to your project or to whatever you're trying to accomplish. Unless you're
Yes,
learning. If you're just learning, go wild. But if you're actually if this is your job, someone's paying you to do this, you're being held accountable to some goals, Like then you have to be intentional about where you're spending your innovation tokens.
Yes, absolutely. Yes, absolutely. That's a wonderful tips for everybody listening to us or watching to this channel. And also, like I think, like in the Kubernetes space, like I see, like we see this kind of a notion, like if we make things complex, this might be a selling point as of today. But
Mm-hmm.
when we go back in the past, like 5 years before, we are seeing projects that are simpler or things you try to make things simpler. That's a business selling point. But
Yeah.
as of today, I feel like if you do complex thing and make it to the market, you might have enough energy to spend and talk to the people on different ways, and might be you have build the business out of it. And
Yeah.
also,
Yeah.
absolutely. And also, I think that as you mentioned during the podcast as well, like we have 4 certification for Kubernetes. And let's say if we introduce 3 certification for the service mesh to operate and manage, this is so crazy. Like you need 7 certification
Right.
in order to do your job.
Yeah.
It is going to be simpler. You just have a one command and everything is stood up. Like
Yeah.
that's the way forward.
Well, this is this is the tension in the Kubernetes space is that, you know, Kubernetes evolved out of a world where everyone was on PaaS, right? And everyone on a PaaS, like the platform was doing everything for you, right? But like that actually wasn't right for a lot of people, And so we went to this world of IaaS or whatever, infrastructure as a service, where Kubernetes, is here and it says, hey, I'm just going to be one portion of this, and you have to like pick these building blocks. So we've kind of swung the pendulum in the opposite direction now. And, the truth is probably somewhere in the middle. Although, I'll say, I do think Kubernetes has actually done a pretty good job. And I think this is part of the success of Kubernetes. I'm going to say something that's very controversial, which is that I actually think Kubernetes is simple, right? And I'm going to use a definition of simple, which maybe is different from the normal definition. But I got this idea from this talk that I watched by Rich Hickey, who's a creator of Clojure, which is like a Lisp-based programming language on the JVM. I never want to use the JVM again. Like I would never personally use Clojure for a variety of reasons. But this talk was really transformative for me because he talked about this idea of like simple versus easy. And that might even be the name of the talk, right? And, in normal language, we conflate those two terms, right? We say, oh, that's simple. Oh, that's easy, right? And we kind of treat them as the same thing. But actually, right, they're two very different concepts. And easy means, oh, I do this thing and like all this stuff happens, but I didn't have to do a lot of work to do it. Therefore, it was easy, right? Whereas simple means, I can understand the pieces here. And even if there are many pieces, they kind of fit together in this logical way where there aren't weird inconsistencies, where you can compose them in like different ways and it kind of all works together, right? So simple as opposed to complex, right? And easy versus hard, right? So easy is like a wizard, right? You install, some complicated thing, you install Microsoft Word, on your computer. There's a wizard and you click, okay, right? That was easy, but a lot of complicated stuff happened, right? Whereas something that's being simple is, it might have pieces, right? But those pieces are well designed. They're composed. I'm repeating myself. So Kubernetes, by that definition, I actually think is simple, right? It's a very logical system. There's lots of things you have to learn. You have to learn, I think I had a tweet at some point which got a lot of retweets where I was like, oh, Kubernetes is very simple. All you have to remember is that the container goes in the pod, and pod goes in the replica set, and replica set goes into deployment, and deployment goes behind a service, and service goes behind a load balancer, and that all goes into cluster, and they get multiple clusters, right? But each of those pieces, like there's a lot of them, but they work together in a pretty reasonable way, right? And I think that's, once you understand the model for Kubernetes and you understand the ways that it can be extended and kind of its boundaries, I actually think Kubernetes is simple, and that's part of its success. So that's all to say, yes, I think simplicity is the key here, but simple doesn't necessarily mean easy, right? Two very different concepts. And I think that's part of why this IaaS space, infrastructure as a service, like the interesting question there is like, if we're talking about simple, well, there was Docker Swarm, right? And why was Docker Swarm? Docker Swarm was a lot simpler than Kubernetes, right? But why was it that Kubernetes was more successful? I actually think in many ways, Kubernetes was just as simple, by that definition, as Docker Swarm. And its power came not just from the community, but from the fact that it was so powerful while yet retaining that idea of simplicity.
Yes, absolutely, absolutely. Like I think I'm completely agree to your point. Like if you look at the Kubernetes and some of its parts, it's so easier to understand. Like if you want to learn pod, you don't need to write down the three different articles to understand what the pod is doing, what the replica set is doing, what the deployment is doing, what the English controller are. There are concepts really simpler and easier to understand with, and yeah, that's gets your under go beneath your brain and will stay forever because these concepts are really easier to understand it.
Right.
So it's really like simple and easier is like two different things to go about.
Right.
And
Now,
also I yes.
there's probably 10,000 people on this live stream saying, I can't believe you said Kubernetes is simple. I have to operate Kubernetes. I hate you. It's not simple. It's really hard. I understand that. Yes, it probably is really hard.
Yes, absolutely, absolutely. So let me like share a good news with the people. Like I share, the Linkerd surpasses Istio adoption in Europe and North America with 118% growth in 2021. So I think we can consider this as a simplicity as well, like easier to operate and manage, give you these
I
kind of
hope so.
results.
Yeah, I hope that's true. And so these results were from the CNCF survey. Every year, the CNCF does this big cloud native survey, and that survey, in 2021, they reported the results in like March of this year, and so we looked at those results and we analyzed them, broke them down, and like it was great. It was a great story for Linkerd. But yeah, I hope that's for reasons of simplicity because we don't have the marketing budget behind some of these other projects, so we kind of have to let the product speak for itself.
Yes, absolutely. And I think but we last time met, we are discussing like, do Linkerd going for the graduation mode? As of today, I can say in public loudly, like this is the only CNCF graduated service mesh in the catalog. Like what it does mean for the graduation for you, and especially if somebody open source project founder listening to us and they wanted to have this project be graduated, what do you think, what should we achieve, what you achieve by graduating this service mesh to the CNCF?
Yeah, so I would say graduation doesn't really change a lot because by the time you're ready for graduation, you've already accomplished like kind of what you wanted to accomplish, right? Like the way you become a graduated project is you have a vast community of adopters from all over the world who are using it for, all sorts of different things, and you have a healthy flow of contributions, and like you've demonstrated the ability to like, have this open source project that have build an honest relationship with your community, and so graduation is like a reflection of that stuff, right? But by the time you've got to that point, you've already like done the stuff you wanted to do. So my advice to people who are who want their projects to be graduated is like, there's nothing special you have to do other than like all of the incredibly difficult, complicated work for growing an open source project. So I would focus on that. If you can build a community around your project that has, that's excited about it, that's telling their friends about it, that's bringing it into their companies, that's contributing back, they feel like, they're part of this project, they feel like it's like, it's important for them, then just focus on that, and incubation and graduation, all that other stuff will follow from there. It'll all follow.
Yes, absolutely, absolutely. And one other topic like I want to address with you is that like we see a discussion around the service mesh versus the API gateway,
Mm-hmm.
and people like to scale like with API management, you think about who can use the API authentication and which edge points
Mm-hmm.
authorization, how to track the use of API, how many calls are allowed per user per endpoint. And with the service meshes, we're talking about
Mm-hmm.
north, south, east, west traffic.
Mm-hmm.
So how you look at these two concepts? Are they related to each other, or they are completely different, or they have a completely different domain?
Yeah, so for a long time, our opinion was, hey, they're two very separate things, right? And like service mesh is just concerned with east-west, and API gateway is just concerned with north-south, and kind of the even the nature of the traffic was very different, right? Traffic coming into the cluster, you're making rules about, individual users, and there's like a bunch of business logic in there, and you're rate limiting because this could be traffic from the outside internet, so you're treating it very carefully. Once you were in the mesh, then like those rules aren't really there. But actually, over time, I think those two things are really converging. And I think one really good example of that is Gateway API in Kubernetes. It's a relatively new API. It was designed originally as a replacement for the Kubernetes ingress resource, right? The ingress resource was like the original way of how you're going to capture ingress, and like it was just very limited. And every project that built an API gateway or an ingress controller for Kubernetes was, basically had to go outside of this ingress resource. So the Gateway API now is a set of CRDs that are designed to be kind of like the more flexible version of that. And it's actually really well designed. We've been digging into it for a reason that I'm going to tell you in a few minutes, but it's really well designed. And it's, it's not just one CRD, it's like a set, and they're interrelated, and like, so, it gets a little complicated, but like Kubernetes itself, it's simple in the sense that each of those routes or each of those CRDs represents something that, can be composed with the other ones. And there's like a logic, and there's a pattern to it. But that Gateway API actually ends up being a really good way to talk about service mesh traffic as well. And so in the upcoming 2.12 release, which I think will be happening next week, we're actually adopting a portion of the Gateway API to describe the newest feature in Linkerd, which is route-based policy, right? So we want to talk about HTTP routes, and we want to say, hey, these routes are allowed from this endpoint, and they're not, or from this identity, and they're not allowed from that identity, right? So how do you express that in configuration terms? Well, we could invent our own thing, and we kind of started going down that path. And then we looked at the Gateway API and we said, oh my gosh, this actually gives us a really nice way of describing what we want to do anyways. So Linkerd is now adopting a portion of the Gateway API, and like that's going to happen, they'll be, assuming things continue to progress in like good ways. And, the Gateway API is not 100% perfect for us yet. It's like 90% of the way there. Assuming that continues to happen, we'll embrace more and more of it. And eventually it might be the case that you describe, you configure Linkerd almost entirely through the Gateway API. And you're actually using that thing to also configure your ingress. So now things are starting to converge a bit, right? Now that the requirements are starting to be pretty, a lot more similar than they were in the past. The other kind of push in this direction is this idea of zero trust security, which is a big, big driver for Linkerd adoption, right? Like probably the number one reason why people adopt Linkerd. It's not the only reason, but the number one today is for mutual TLS, right? And for zero trust security. And what zero trust security means is that you don't really have this firewall anymore, right? You no longer have this like hard shell, where all the bad guys are like out there. And then the inside is like, oh, everything's trusted and everything's okay. Instead, you don't trust the network at all, right? And everything has to have its security perimeter, right? Every pod has its own perimeter. And Linkerd is great for that, right? Because it's running in the pod. It can do the mutual TLS. It can do policy. You can do whatever you want. Everything's enforced all the way. But now that is starting to converge, right? So that sounds a lot like, well, API gateway, used to be our firewall, used to be protecting our cluster from the bad guys. But now we're not really, that's not enough. Every pod has to do that work too. So those are two big ways where the world of API gateways and the world of service meshes are really starting to merge together. And I think we'll continue seeing that trend.
Absolutely, absolutely. And also, like another question, like we talked about last time when we met as well, like do we think about the API gateway as a SMIs in service mesh? Like is in theory it just saying we are the SMIs, we have interfaces of the service mesh, and today you're using, let's say, Linkerd, tomorrow you're using Console or Toma. We give you the library to pick and choose and swap between them. So is this first to the SMIs as well, like what's happening later happening in there. Plus we can see like is it the similar way of gateway API in the ingress controller, or how we look at this space like gateway API.
Yeah. So, a lot of service meshes are now starting to adopt the Gateway API. A lot of the ingress controllers are too. So yes, I think it's becoming a standard in the same sense that SMI was, which was like, hey, we want to have, a set of APIs that allow us to configure, a service mesh kind of independently of the implementation choice. Now, the problem with SMI, so the SMI folks are actually starting to migrate to the Gateway API too. The problem with SMI was that there never was really a reason to use it, right? There were no tools that were really, Flagger was built on top of a portion of SMI. There just weren't enough tools that really made it a useful API for anyone. And the idea operationally that you were going to switch from Linkerd to Istio and it was just going to be like pressing a button, it's like not a realistic operation anyways. Like people weren't really doing that. So it became kind of this empty API. It was like a marketing tool for OSM. Oh, we have, we're the SMI first API, but like that was it, right? And so the big difference, I think, between SMI and the Gateway API is that the Gateway API is actually built into Kubernetes. And that's a big, big advantage. That means that we as Linkerd, and if it weren't for that, we might not care about it as much, right? But I hate introducing CRDs into the system. I hate adding more CRDs. I think that just makes things more complicated. So if we can rely on these existing CRDs that are already there, even if they're not perfect, that's a big advantage for Linkerd users. So I think that's the big difference between those two. Yes, I do think it's becoming it will over time become kind of a standard. Standard is kind of a dirty word in my mind, and I have to make a face every time I say that word, standard, because I think, wow, I'm writing a blog post about this. I think standards are like in Kubernetes, in the cloud native world, standards are kind of like they become weaponized. But it does seem like that's what's happening. And certainly from the Linkerd perspective, if the Gateway API continues to advance in a way that makes sense for Linkerd, we're going to keep adopting it. And if it goes into some weird direction, then we'll just, do something else.
Yes, and also before I let you go, like what's the next set of plans before we end this year, 2022, for the Linkerd users? And plus, what we see in the KubeCon, if we been traveling to the KubeCon Detroit, I think
Yeah.
it's after 2 months.
Yeah, that's right. So, Linkerd will be there with bells on in Detroit as always. We're always there, and it's always a good time for us. We had a whole bunch of talks accepted about Linkerd. Interestingly, this KubeCon, we normally get a whole bunch of end user Linkerd talks. This KubeCon, none of those end user talks were accepted. So the talks that were accepted were kind of like service mesh implementation talks, which is interesting. I'd prefer more end user talks, but that's fine. Maybe people are tired of hearing about how many amazing ways people use Linkerd. So maybe it's time for Linkerd Con or something. But we'll all be there. Linkerd 2.12, like I said, will be out next week with route-based policies. So that's a big, big step for anyone who's doing zero trust networking or any kind of security conscious adopters. And then after that, 2.13, which should be out before the end of the year, we'll finally have circuit breaking. It's like we've been putting that off, but now we're going to do it, and header-based routing. So we got a lot of exciting stuff on the roadmap. A couple other features that we're working on that I think will be exciting. Maybe there'll be some eBPF in there. You never know. That's kind of our plan. And then on the Buoyant Cloud side, of course, just trying to build this automated system to monitor Linkerd everywhere, manage it for you, do automated upgrades and installs and certificate rotation and all that stuff. So, if you want to operate Linkerd yourself, you're welcome to, and we try and make it as simple as possible. If you want to just have Buoyant handle it for you, well, you can pay us money and we'll just manage it for you. And, you should do what's right for your organization. We're happy. As long as there's Linkerd adoption, we're happy either way.
Yes, absolutely. And as you mentioned, like the end user talk are the wonderful way to tell people like we use Linkerd and we get the benefit. So I think for the previous KubeCon, we have wonderful talks, and one of them I really enjoyed that how the Xbox gaming secure 22K port with Linkerd.
Yeah.
So I like this talk. Like you mentioned a good thing. Like we have to see more and more end user talks. So people telling me like this is the way we're using it. This is the things we achieve by using it.
Yeah. I even did a keynote in the previous KubeCon EU, which was virtual. Which is too bad because I would have loved to have done this in person, where I just talked about all the ways that people were using Linkerd to fight COVID-19.
Yes.
And it was so awesome to be able to talk about that because I had never imagined that as being a use case for Linkerd, right? So there's all these really interesting use cases out there. Sadly, none of them are going to be featured at KubeCon, but I'll be there, and a bunch of the Linkerd maintainers will be there, and we'll have some really good talks about, kind of the internals of Linkerd and how it works, and future plans and things like that.
Yes, absolutely, absolutely, and might be in the future we can see a Linkerd con,
Yeah.
or if you are interested in doing some kind of like you can talk to me. Like I'm also running a Kubernetes community days Pakistan,
There you
so
go.
you can also go as tell us like your Linkerd talk as well. So guys, mentioning some comments, you guys have a good articles on managing Linkerd with GitOps using Argo, Cert Manager, and Seal Seeker,
Yeah.
and also do you have some insight on what challenges can come with scaling Linkerd or multiple clusters using GitOps? Is GitOps the recommended way to manage Linkerd?
Yeah, great question, Kai. So yeah, I'm a big fan of GitOps. I think that it makes a ton of sense for that to be kind of the primary mechanism by which you manage Linkerd, because everything gets captured in code and like all the changes are tracked and so on. When it comes to multiple clusters, the thing that gets a little challenging there is if you're doing cross-cluster communication, the TLS certificates have to be set up in a particular way where you need a trust anchor that is the same across all clusters, but you need the issuer certificates to be different across different clusters. And if you don't have that, then cross-cluster communication is not going to work with Linkerd because it's not going to have the identity kind of chain that it wants. If you're just doing cross clusters and if you're just doing multiple clusters and you don't need cross-cluster communication, then like you can ignore all that, although maybe you think about it because it's good for security. And managing that purely through Argo or Helm can be a little tricky. Not impossible, but it can be a little tricky. That's where things get nuanced. And then, even with Buoyant Cloud, where we're taking over Linkerd management for you, we're still following this GitOps approach where, you have your GitOps pipeline put onto the cluster, not a Linkerd manifest, but like a little CRD that says, hey, please install Linkerd 2.12 or install Linkerd 2.12 or whatever it is. And then we have an operator that kind of does that work for you. But either way, you're driving those changes to your infrastructure through GitOps pipeline, whether that's Argo or Flux or something else. It doesn't really matter. I think what's important there is your changes are tracked in version control and you can reproduce everything. And no one has to wonder, how did this cluster get to be this way, right? Because that's always a little scary.
Yes, absolutely, absolutely. And for the hands-on stuff, there's a link, Service Mesh 101 Introduction to Linkerd, that's available on the Buoyant webinars as well. And also the friend of our Victor Farsig, like a wonderful Linkerd videos on his channels. What is Linkerd, Kubernetes, Service Mesh. So you can watch those as well. And this is also, we have some hands-on dive on Cloud Native Islamabad as well. And we continue to hope do more and more as we have no features in it. Always pleasure talking to you, William, on this topic of Service Mesh and all these kind of activities. And hopefully, if I am able to join you at the KubeCon in person, I will definitely have an in-person podcast as well with you. That's a really dream of mine. So we're
Right.
meeting you and telling you and have a good coffee with you. So it's been a pleasure talking to you. So
Yeah.
any last words for anyone listening to us or watching us?
I just remembered that the other thing we're going to have at KubeCon is we're going to have an in-person workshop. So you should be able, Linkerd 101 in production, everything you need to know. So if you're going to be at KubeCon, sign up for that workshop. It should be somewhere in your KubeCon registration. If not, no worries. We produce all those videos and stuff like Siam was pointing out. And really, that's it. Thank you so much for having me. This has been a great conversation.
Yes, absolutely. And thanks, Kai, for the wonderful comments and watching to us on this podcast. So I hope to see you again, William. I'm looking forward to meeting you at the KubeCon. That's right, for the in-person podcast. And thank you very much for joining us and describing all the wonderful details on Linkerd, eBPF, Sidecar, Service Mesh, API Gateway. And hopefully we covered a lot on this channel, and this has been a good learning session for everyone who's listening to us or watching us. Stay safe, stay healthy. Bye bye, everyone.